Okay, Carter, Aliyah, and Jake. It looks like your book didn't go really into depth on this piece, but I have this problem here. Again, L sub n is equal to 2 over n summation from I equals 1 to, forgot the n up there, my bad. We'll put that n up there. 1 plus 2 parentheses I minus n over n. And you want to write it as n, you want to find the limit, and you want to choose which one of these it actually represents the integral of. And it's a really good problem, and it was confusing me at first because I've never really gone that direction with it, but there's a couple reasons why it's confusing, and I had to figure out why. And when you guys left for about 5 minutes, it really came to me, and I thought, well, what's the best way to teach you guys how to do this? And I realized that the best way would be to teach you how to do right hand and left hand limits using a given function. So, for example, suppose I had the function or the integral, for example, the integral, and we'll go from, let's go from 0 to 3, and let's go 2 plus 4x dx. Well, what we learned last year was this. This is what I told you. And I was right, but it's just a slightly different way of looking at it. So we said the integral from a to b of f of x dx is equal to the limit as n goes to infinity of the sum from I equals 1 to n of f of x sub I delta x. And we said that delta x is equal to b minus a over n. We said x sub I is equal to a plus b minus a over n times I. And remember, I always think you guys remember everything, and obviously you don't. Nobody does. I don't remember anything either. But this is the width, and hopefully you understand that we take b minus a and then divide it by n. That gives us the width of each rectangle because we have n rectangles. And then as a, this just is where we evaluate the spot. So, for example, if we take an interval, in this case, we only go from, say, 0 to 3. So 0 to 3, you know, we have 1 and 2 there. So we're going to start at A, which is 0, and we're going to go over 1 width, and then we're going over 2 widths, and we're going over 3 widths. So if you're doing the right hand, you'll evaluate at 1, 2, and 3. If you do the left hand, you evaluate at 0, 1, and 2. So this is kind of the trick that you gotta kind of see and think about and get used to. My smartboard froze up here. But in order to represent this, notice that the right hand is on top. Right hand, so we're going to use I to represent the right hand. But the left hand, well, that's the 0, 1, and 2. And that would be I minus 1. And so if you notice in your example that you were given here, you've got that I minus 1, and that tells us that it's the left hand, which is currently given to you. So I only taught you to do the right hand last year. Why? Because the right hand of an infinite number of terms is the same as the left hand of an infinite number of terms. It doesn't matter if it's right or left. And so we just chose the right and we ran with it. Your book is asking you to do the left. So we're going to take that sum and we're going to roll with it. And we're going to do the right hand piece and we're going to write it out just so you can remember how that goes. Okay? You can remember how that goes. And so what I have is for the right hand sum, we are going to have, first of all, delta x is equal to 3 minus 0 over n, or 3n. 3 over n. And x sub I is equal to, we take a, which is 0, and we add that to 3 over n times I, or 3 over ni. So when you actually plugged in this right-hand sum, what you had was the limit as n goes to infinity of the sum from I equals 1 to n of, and we plug these in. Okay? This is my delta x, and I take this and I plug it into the function. So it's 2 plus 4 times 3 over n I. And all of that times 3 over n. Now, they wrote it out front, so I'll write it out front. And there's your summation. Okay, there's your summation. If I did a left hand, it's just slightly different. The left hand, I know that delta x is still going to be 3 over n. But x sub I is equal to 3 over n times I minus 1. We do I minus 1 to show that offset that I showed you earlier. So we have the limit as n goes to infinity of 3 over n times the sum from I equals 1 to n of, and we then plug this into our function, 2 plus 4 times 3 over n times I minus 1. Okay, and that's what we type in. Now, I haven't worked this out yet, but I'm going to see if the right hand and the left hand actually come out to be the same. And then I'll continue on with the problem. But I think that'll be really cool. If you guys don't want to watch, then you can just fast forward through the video. Who really cares, right? So we're going to do the right hand. This is fun. Right hand. And that equals, and this preps me for Monday anyway, because we're going to do this on Monday. So I got 3 over n. Sum I equals 1 to n. And we've got 2 plus 4 times 3 over n I. Okay, well, you've learned how to deal with that. We did that last year, and we said that's 3 over n times the sum from I equals 1 to n of 2 plus 12 over n times I, which is the same as 3 over n. I'm going to divide up into two summations now. Sum from I equals 1 to n of 2 plus 3 over n times the sum from I equals 1 to n of 12 over n times I. So let's look at what you get. 3 over n times the sum from I equals 1 to n of 2 plus 36 over n squared times the sum from I equals 1 to n of I. And now we did some substitutions. Hopefully remember that this one will come out to be 2n. So you have 3 over n times 2n over 1. The n's cancel, you're left with 6. Plus, here you have 36 over n squared times I, you substitute n times n plus 1 over 2. Well, shoot, now I got to work that out. So that'll be 36n squared plus 36n over 2n squared. So 6 plus, what do we factor out of the top? We factor out n squared. You get 36 plus 36 over n. On the bottom, what do we factor out? We don't need to factor anything out. The n squares cancel. That goes to 0 when you let n go to infinity. You get 18. So 6 plus 18 is equal to 24. And that should be our answer for the right hand. I'm going to work it out the left hand. Now, I know you've seen that right hand workout before. I know you have. And so I'm not really worried about you following that. You've seen that. You saw it all last year from me. I'm just going to check 2 plus 4x. I'm going to type it in my calculator, and we're going to calculate the area, number 7, and we're going to go from 0 to 3, 0 to 3. And hopefully I get what I was saying. Yep, I got that 24. I got that 24. So you haven't seen this left-hand workout before. We haven't done that. So what happens if we do the left-hand piece? Well, I'll write that out. Let's write that out. So we have we have the left hand is equal to 3 over n times the sum from I equals 1 to n of 2 plus 4 times, and what do we got? I can't even remember here. We've got 3 over n, 3 over n times that I minus 1. That's what you got. Well, let's work that through. Let's see what we get. Three over n times the sum from I equals 1 to n of 2 plus, let's see, that ends up being let's see, we'll go sum from, oh, 3 over n times the sum from I equals 1 to n of, we'll write it as 12 I over n minus 12 over n. I think you guys see that and like that. And watch what happens. We have 3 over n times the sum from I equals 1 to n of 2 plus 3 over n times the sum from I equals 1 to n of the 12I over n minus the sum from I equals 1 to n. We have the 3 over n out front, 12 over n. And remember, what we do is we just get rid of everything that doesn't have an I on it. And so this one is 3 over n, and you'll multiply by 2n. Well, we saw that's going to give you 6. We saw that before. Look at this one. This is going to be plus, we're going to get 36 over n squared times the sum from I equals 1 to n of I. Well, we worked that out. That was the exact same piece that we worked out before. We worked out that same piece right here. Okay? And we came up with 18 out of that. Well, minus this one, you're going to end up with 36 over n squared times the sum from I equals 1 to n of 1. And this ends up being then 36 over n squared times, this is just n, which is 36 over n, which that's just going to go to 0 when you let n go to infinity. So the left hand always just produces this extra piece that just goes to 0. And so you can see we still get 24 here. So you've seen that whole thing work out. The left hand and the right hand, it all works out the same. Let's go to the actual problem that you guys were working on and do that piece. You guys have written it as n. You did 2 over n times the sum from I equals 1 to n of 1 plus 2 over n times the sum from I equals 1 to n of, and I think you wrote it like this, Jake, 2I over n minus a sum from 2 over n, sum from I equals 1 to n of, we're going to 2 over n. So you end up with 2 over n times n, because n will be substituted there, plus this will be 4 over n squared times n plus 1 over 2, minus, and this will be 4 over n squared times n. This is 2. This will be 4n squared plus 4 over 2n squared, which is also going to be 2. And this will be 4n over n, which is just going to be 0. So we have 2 plus 2, which is 4. So we found the limit. We wrote it just in terms of n. And now we just have to figure out which one it matches. Which one does it match? Well, because it's the I minus 1, and because it says left hand, I know that it's left hand. So what this tells me right here is that my delta x is 2 over n. And what it tells me is that my x sub I is, if you look at here, my x sub I is 2 over n times I minus 1. So it's going to match with the 1 plus x from 0 to 2. Because you can see the 2 to the 0, that gives you 2 over n. And they all give you 2 over n. But when you take the 2 over n times I minus 1 and plug it in here, then that's what you get in your original picture, in your original piece. And if you went through and calculated the area for all of these, if you went ahead and calculated the area, you should come up with 4. And sure enough, in this one, the integral from 0 to 2 of 1 plus x dx, we take the antiderivative of 1, we get x. Antiderivative of x is x squared over 2. And you integrate it from 0 to 2, we'll end up with 2 plus 4 over 2, or 2 plus 2 is 4. And so you do get that value. So it is this one right here. It's letter C. And that works out. So that was a lot of work. As I look back at it, I really took a long time to explain it, but it's there's a lot of steps that are involved there that I would have probably taken 3 days to go over with you guys to really understand and appreciate it. But that's the nature. And I mean, if you try integrating all these other ones, I mean, like for example, number 1, you have x squared over 2, evaluate at 3 and 1. Well, you get 9 over 2 minus 1 over 2, and that's 8 over 2, which is, well, I guess that's still 4, isn't it? But the original shape, I'm pretty confident is going to be this 1 plus x guy, and I think I made my case for it. So, sorry, I guess if you didn't follow that, then I don't know what to do. So.